Hello everyone, let's talk about an easy problem on linked list today. Leetcode 141 linked list cycle. It says that given a head of the linked list, determine if the linked list has a cycle in it or not. Return true if the cycle exists, otherwise return false. And then it says that there is a cycle in linked list if there is some node in the list that can be reached again by continuously following the internal next pointer. Internally, pause is used to denote the index of the node that tail's next pointer is connected to. Note that pause is not passed as a parameter. Return true if there is a linked list in the cycle, otherwise return false. And as you can see, there is no uh, what you say pause parameter passed to it, only head of the linked list, and then it expects a boolean which is true or false depending on if the cycle exists or not. Then there are some examples here. So it's in this first example, we can see that there is a cycle starting from position 1 and from node 2. And then, and once we start traversing this list, we will be stuck in an infinite loop if we are just trying to find the end of the list in linked list, because we will be just continuously going into the cycle here. Similarly, here there's a small cycle starting from position 0 from node 1 to node 2, and then the last example where there is only one node and no cycle, we return false. Now let's jump into the solution space, understanding how we can solve this problem. Now there are multiple solutions possible to this problem. One of the easiest way we can one data structure we can use is hash set. The reason is like it can be used as simple visited set, where we can just keep a set of visited nodes that we have encountered, and if we see a repeat of it, that means the linked list has cycle. Otherwise, we can if we reach to the end of the linked list, that means the linked list has no cycle. uh, so we can actually quickly look at the example here. Suppose we create a set, say let's start here. Yeah, and we encountered 0. So we have not seen it so far. We will just add it to the set. Then we see node 1. So we add it to the set as well. And then we see 3, which is again not part of the set. So we will just add it and continue like this till we reach either the end of the linked list or we see them again. So let's see. So now we see we have not seen 2 so far. We will just add it to the set. Then we go to the 4 and again add it to the set. Now comes the interesting part. Like as soon as we edit 4, it points us, it takes us back to 2. And now we can say that 2 is actually already part of the set. And that means we have seen the node again. And that means there's a cycle. So in this case, we'll just break out and return false in this case. But let's think about if in this case the time complexity will be O of n, because we are traversing through the list once, and the space complexity is O of n as well, because we have to maintain this visited set, uh, and that requires n elements to be stored into the list. But can we do better? As a computer scientist, we always think about can we actually do better? And the answer to this is yes. So let's think about the case similar to like physics, or where we have a concept of relative velocity. Suppose we are in a circle somewhere, and in that circle we see that okay, this there are two cars running right in this track. One is a fast car and another one is slow one. And if we just keep on rotating that circle, the fast car will one day or one time at least meet the slow car, and this will keep on happening if we do it n number of times. And this is where we have this problem called Floyd cycle finding algorithm, or um, we sometimes call it like a turtle and hare approach, where turtle is somehow slower. And we will be just using the term fast pointer and slow pointer. This is our fast car and this is our slow car. So what we will do is like the fast pointer will move um, two times compared to the slow pointer. So in a physics velocity way, the relative velocity will be like one for between the two cars, because fast pointer will be uh, just be like two times as fast as the ones slow pointer, and initially both of them point to the head. Then what we will do is like in first iteration, slow pointer will move by one and fast pointer will move by two. Then we continue, and now slow pointer reaches three, but fast pointer is already in the loop. And as we discussed earlier, once they are in the loop, one time at least they will meet in one of the iterations. So let's see when. Then we continue. Slow pointer reaches 4, but fast pointer reaches 6. Uh, and then fast pointer reaches 4, but slow pointer is at 5 now. And this continues. And finally, slow pointer moves by 1 to 6, and fast pointer moves from 4 to 6. And eventually they have met. So um, that means we have actually found the cycle. They cannot meet if there was no cycle. Let's look at another example why they will never meet. So suppose there was no cycle at all. In this case, what will happen is fast pointer will just move by 2, slow pointer by 1. Fast pointer will be out of the race or out of the road itself, um, but slow pointer will be just somewhere in the in the center or middle of the linked list somewhere. And But fast pointer will automatically be out of the linked list. So we can say if there is a cycle in the list, slow and fast pointers will meet. But if there is no cycle in the list, that means slow and fast pointer will never meet, and we will end the loop. Now let's jump onto the code. Um, like we first discussed, we will need a slow pointer pointing to head, and what we will also need is fast pointer pointing to head as well. And now what we have to do is like, because fast will be ahead of slow all the time, at least if the list is straight without any cycle, um, we have to check for null on it rather than on slow, because if fast is not null, slow will anyways not be null. But if fast is null, that means we should break out of the loop. Otherwise, we may get a null pointer exception. And I think that's what program or the interviewer want to test, like if you can think of those edge cases. So what we will do is like if fast dot next is not equal to null, and fast dot next uh, not equal to null. We are checking this first because if we reverse the condition, this may result in null pointer exception. So the order matters here. And then what we will do is like we will do slow is equal to slow dot next, because slow pointer moves by 1. And similarly, fast moves by 2 now, because that's what we want to do. And now we want to check if at any point slow and fast are same. That means we have a cycle. So let's do that. Slow and fast are same. Then we return true. Else, if we are out of the loop, in case of the no cycle case, we will anyways return false. So I think that should be enough. Let's now run the code. Okay, there is some Error in my code. Okay, because I am actually outside the function, and I'm returning the false in the class. So I think that was the reason. So I think now hopefully this fixes it. So now I'm getting a null pointer exception on my code, and this means one thing. So it complains on line number 16. This can only happen when the incoming node is null. So what we can do in this case is we can simply put a case that if head is equal to null, that means return false, because yeah, in this case there is no list at all, so no cycle as well. So let's see if this fixes it. Awesome. Yeah, that was the reason. And that's it, folks. See you again in some other video soon. Thank you.